but there are various pathways how digital innovations can really contribute to pesticide risk reductions and still having a very successful crop protection, which is the main goal, of course, and likely having also economic viability. So I would like to use this structure here to classify technologies. So you see on the top the potential to reduce pesticide use and risk per hectare, so could be low or high, and then the potential to be scaled, for example, based on the economic performance, the cost, but also regulatory hurdles that actually kick in for some of these technologies. So clearly, if you have low, so scalability low and reduction potential low, it's not a viable pathway, so we can forget about that group. However, there are other technologies like controlled traffic farming, variable rate technologies that actually have a low potential to reduce pesticide use, but low doesn't mean nothing. So there is an important reduction possible. However, they can be scaled very highly. So that's why they are super important and super promising, even though they only reduce pesticide use by by a few percent. On the other hand, we have technologies that really have the potential to replace pesticide use in a but totally or largely, like in the systems that are depicted here with breeding robots, controlled environment agriculture, and so on. However, they cannot be scaled. And the scaling potential, of course, that differs a bit across the globe. So currently, for example, unmanned aerial vehicles are still highly regulated in European agriculture, and others they are not. So that's why also it's very context specific how you rank that. And then, of course, there are these things that might in the future be scalable and have the high potential. And in my view, that connects to this information sharing, to the change of agricultural landscapes in the future. So here's really like a very important element where we have likely really a high potential to be scaled and high pesticide reductions being possible. So that's a bit the overview. But of course, I want to come back to that initial idea. So all of these technologies can support efficiency, substitution, redesign, and with that also contribute to make IPM more widely used and like have a deeper IPM use to support also these systems with not only fewer but also without pesticide use, like pesticide-free or organic production systems.